Chemistry. Water. Module 1. Water. We take this important resource for granted. Water is one of the most important natural resources. This chapter helps us 1. To know about the different states of water. 2. To learn about water cycle and water pollution. 3. To study the importance of water for all living things. 4. To learn about different methods used for purification of water. 5. To study about water as a solvent, and to prevent pollution of local water sources. Connect with me via WhatsApp, +234 703 247 4726, to get more interesting videos. Please, to support our ministry, remember to like the video, and also find it in your heart to subscribe to our YouTube channel and then gently tap the bell to turn on the notification, so as not to miss out on the next videos. Water is the second most important life-sustaining substance. Water occurs all over the earth. Water covers nearly 3/4 of the Earth's surface in the form of rivers, seas, oceans, lakes, ponds, etc. Water is also found under the ground. In the atmosphere, water is present in the form of moisture, mists, clouds, etc. Why is water important? Can you imagine life without water? All living organisms have a high percentage of water in them. About 90% of human blood is water. Food grains, fruits and vegetables contain water. We need a lot of water in our daily life for different purposes. 1. Water fulfills our biological needs like thirst and hunger. 2. Plants take nutrients from the soil. They cannot take these nutrients directly as we eat food. The nutrients are dissolved in water present in the soil. It is this water that is absorbed by the plants for their nutrition. 3. Water is needed for agriculture. Crops cannot grow without water. Without crops, man cannot obtain food for survival. 4. Water controls the Earth's climate. 5. Industries use water as a solvent and as an ingredient for producing goods. 6. Water is used for cooking food, bathing, cleaning, and washing. 7. Water is used for preparing medicines, injections, and tonics. 8. Water is used to manufacture oxygen and hydrogen on a large scale. 9. Most aquatic life can survive only in water. 10. Water falling from a height, waterfalls, is used to generate electricity. The list is endless. Water content in some foods. Most foods contain a large percentage of water. We cannot imagine these foods without water. In milk, there is 95% of water. Egg usually contains 75% of water. Tomatoes contains 95% of water. Butter also contains 95% of water. Potatoes contains 75% of water. Bread contains 25% of water. Watermelon contains 97% of water. Meat is said to contain 75% of water, while 70% of the human body is water. Natural water and its sources. Natural water is classified into the following 4 types. 1. Rainwater. 2. River and lake water. 3. Spring and well water. 4. Ocean and seawater. Sources of water. Natural water is found as 1. Surface water. 2. Underground water. 3. Above surface water. 1. Surface water comprises of water in the form of snow, frost, rainwater, river water, lake water, and seawater. The oceans and seas contain almost 97% of the Earth's water, and is the largest source of natural water. Ocean water has the largest amount of dissolved impurities. The main impurity is salt. As the concentration of common salt in seawater is very high, it is used to manufacture salt by evaporation. Ocean water cannot be used directly for drinking or irrigation. Water in rivers and lakes comes from rains, and the melting snow on mountains. It flows down the mountain slopes and plains before joining the sea. On its way, the river water dissolves many substances, especially mineral salts. River water has suspended impurities. Water facts. 1. About 75% of the Earth is covered with water. 2. About 97% of Earth's water is in oceans. 3. Only 3% of the Earth's water can be as drinking water. 4. About 75% of the world's fresh water are frozen in the polar ice caps. 5. Although a person can live without food for more than a month, a person can without water for only 1 week. 6. During ancient times, a person used only 20 liters of water per day. Today we need about 10 times this quantity. 7. It takes 4 to 8 liters to brush your teeth, 20 liters to flush a toilet, and about 200 liters to take a shower bath. 8. It takes about 8,000 liters of water to make 4 new tires. 9. Water gets polluted due to oil spills, fertilizer and agricultural runoff, sewage, stormwater, industrial wastes, etc. 10. Ancient Egyptians treated water by siphoning water out of the top of huge jars, after allowing the muddy water from the Nile River to settle. 11. Hippocrates, known as the father of medicine, directed people in Greece to boil and strain water before drinking it. In the 1950s, scientists began to suspect that water might carry diseases. Although earlier treatment of water could make the water safer, it was mainly done to improve the taste, smell or looks of water. River and lake water are often the largest source of drinking water for urban areas. 2. Underground water comprises of well water and spring water. As water flows over the ground, a part of the water percolates through the upper layer of the Earth's surface and collects on the solid rocks deep underneath. The water then runs along the surface of the rock, and may again come out on the surface of the Earth as a spring. A well is dug to draw on the large reservoirs of underground water. It contains dissolved impurities. Well water is safer to drink relative to river water. Spring or well water is next to rainwater in purity. A sample of water from springs and wells leaves a great deal of residue on evaporation. However, this residue consists of dissolved salts which are not poisonous. The water does not contain suspended matter or germs, as it has been filtered through different layers of soil. The taste of spring water differs from place to place. Sometimes this water is rich in minerals which have medicinal value. 3. Above surface water occurs in the air as moisture and in clouds. The occurrence of rain is a clear evidence of the presence of water in air. Rainwater is almost pure water since it is formed by evaporation and condensation of water vapor. Rainwater has a greater ability to dissolve salts as it is almost pure. Rainwater dissolves gases present in air, and also collects dust particles, as it falls. Thus, the only impurities in rainwater are dust and dissolved gases such as oxygen, nitrogen, and carbon dioxide. Since these gases are not poisonous, rainwater is safe to drink. 6.5. Impurities present in water. Water has 2 types of impurities, dissolved impurities and suspended impurities. River water is the most suitable source of water for domestic and industrial use. River water or lake water is absolutely unfit for drinking directly, due to the presence of dissolved and suspended impurities. This water must first be purified. Air has moisture. Take a few ice cubes in a dry glass tumbler and leave it on a table for some time. What do you observe? We notice water droplets on the side of the tumbler. The water droplets would only have come from the air surrounding it. This proves that air itself is always moist. We may therefore conclude that water occurs everywhere on the Earth's surface, above it, and below it. 6.6. The three states of water. Water occurs naturally in the three physical states as follows. Solid state, snow and frost. Liquid state, in different water bodies like river water, seawater, and lake water. Gaseous state, water vapor or moisture in the air. Water at room temperature is a liquid. Water when heated to 100 degrees Celsius begins to boil, and changes to water vapor, steam. At 0 degrees Celsius water changes to the solid form, ice. Ice, water, and steam seem to be different substances, because they have different physical properties. However, chemically they are identical. Ice, water and steam are the same chemical substance in different physical states. When you apply heat to ice, it turns into water. The process is called melting. It means solids can melt to become liquids. On further heating of the water, it turns into water vapor. The process is called vaporization. It means liquids can vaporize to become gas. On the other way round, when water vapor is cooled, it turns water. You can say condensation or liquefaction has occurred. It means gas can be condensed or liquefied to water. Then, when the water is freezed, it turns into ice. The process is called freezing or solidification. It means water can solidify to become ice. This is a simpler schematic representation of what has been explained. (6.7) Need for potable water. Water is needed for consumption by humans, animals, and plants. Such water is called potable water. Characteristics of potable or drinking water. Water must have the following characteristics to be potable. 1. Water must be free from harmful substances and germs. 2. Water should be colorless and odorless. 3. Water should be transparent. 4. Water may have some minerals dissolved that are necessary for our body. These minerals give a unique taste to water. The problem with the availability of potable water is as follows. 1. The water available naturally is mostly unfit for use, due to the presence of impurities. 2. Fresh water is available only in the polar regions as ice, and hence unsuitable. 3. Almost 97% of the water on Earth is present in oceans and seas. Such water is salty and unfit for use. 4. Water present in lakes, rivers, springs, and wells can be used, but it contains many impurities, which might be harmful. Besides these impurities, it gets polluted by harmful industrial and agricultural waste products too. Water is also contaminated with germs that may cause diseases. River and lake water is the single largest source of water. There is a need to purify river and lake water before it can be used. 6.8. Purification of water for drinking. For cities and towns, the source of water is the nearest river or lake. This water contains both suspended and dissolved impurities. Before supplying it for drinking purposes, it is necessary to purify this water. Purification of water in cities involves the following operations. 1. Sedimentation. When running river water is permitted to flow into basins, tanks, or reservoirs, most of the suspended matter settles to the bottom. To make the sedimentation faster, a special chemical called alum is added. This makes precipitation, of fine clay and soil, faster. 2. Filtration. Limited quantities of suspended impurities may be removed by filtration, using a funnel and a filter paper. But for purification of water to be supplied to a town, water is filtered by passing through beds of sand and gravel. This process removes suspended matter. A sand filter is shown in the above figure in step 2. Now, the water is clear. But this is not necessarily pure, as it may contain organisms like bacteria. 3. Disinfecting water by chlorination. Bacteria are small organisms which can be seen only through a microscope. Their presence in water may cause diseases like dysentery, typhoid fever, enteric fever, cholera, diarrhea, etc. To remove these harmful organisms, the germs must be destroyed. Removal of germs is generally known as sterilization. The following are some of the methods of killing bacteria in water. A. By boiling. Bacteria cannot exist at the temperature of boiling water. Therefore, prolonged boiling will destroy them. However, the method can only be applied at homes for limited quantities of water. B. Chlorination. Water when treated with chlorine kills bacteria. Treatment of water with chlorine is called chlorination. This method is preferred for large-scale disinfection. Tap water still contains dissolved minerals which give the water a distinct taste. Distilled water is insipid and has no taste. 6.9. Physical properties. Water has the following properties. 1. Color. Pure water is colorless, odorless, and a transparent liquid. 2. Taste. Drinking water has a slight taste due to the dissolved minerals and gases present in it. Distilled water has no taste as dissolved impurities and gases are not present in it. 3. Boiling point. Pure water normally boils at 100 degrees Celsius. The presence of dissolved impurities increases its boiling point. 4. Freezing point. Pure water normally freezes at 0 degrees Celsius. The presence of dissolved impurities decreases its freezing point. 5. Conductivity. Pure water is a poor conductor of heat and electricity. 6. Solubility. Water is a universal solvent. Water is introduced from a source, into the sedimentation tank, and it is allowed to settle and sediment for a while. The sedimented particles are then tapped off, to give a clearer water surface. Then, the clear water is passed into a filtration tank, containing sands, first layer down, and charcoal, second layer down. Sand filtration is used for the removal of suspended matter, as well as floating and sinkable particles. The wastewater flows vertically through a fine bed of sand or gravel. Particles are removed by way of absorption or physical encapsulation. Activated charcoal is the ideal water filter, because it removes toxins from the water, without stripping the water of salts and important minerals. The filtered water is then tapped off into a chlorinated tank, which a chlorine cylinder is attached to it, for continuous chlorination of the water. To prevent contamination with germs, water companies add a disinfectant, usually either chlorine or chloramine, that kills disease-causing germs such as Salmonella, Campylobacter, and norovirus. Then, drinking water can now be collected from the tap. Water as solvent. When a solid substance dissolves in a liquid, the solid is called solute and the liquid is called solvent. Water is a solvent that dissolves many solute substances. Example: sodium chloride dissolves in water. Sodium chloride is the solute, and water is the solvent. Why is water known as a universal solvent? Water is known as a universal solvent, since it dissolves a large number of substances. Water acts as a solvent in numerous industrial and agricultural processes. 6.10. Importance of conservation of water. The basic uses of water fall into the following categories. A. Generally, for drinking, washing, cooking, bathing, cleaning, etc. B. Metabolic processes for photosynthesis by plants, and excretion by animals and humans. C. Firefighting. For extinguishing fires, either directly, or as a constituent in a fire extinguisher. D. Transportation. To serve as a means of transportation for ships or boats. E. Industrial uses. F. Generates electricity, in hydroelectric power stations. G. Agricultural uses, for irrigation, and for spraying insecticides. Water is a very scarce commodity. Purification of water for human consumption is expensive. We must not waste water, even a drop of it. Conservation of water is the means of preventing wastage of water. This also helps to protect the limited sources of water from getting exhausted. 6.11. Important points to remember. Water, like air, is the most important commodity for survival of life. Water is a compound of hydrogen and oxygen, combined in the ratio 2:1, and having the formula H2O. Water occurs on the Earth's surface, as snow, frost, rainwater, river water, lake water, and seawater. Water occurs below the Earth's surface, as well water and spring water. Water occurs in living matter, including human beings, vegetables, milk and eggs, and cereals. Water exists in 3 states: in solid state as snow, ice, in liquid state as seawater, river water, and in gaseous state as moisture in air. The 3 states can be interchanged. Ice, on melting, changes to water, which on heating, changes to steam. Rivers and lakes are the main sources of water for human consumption. River water contains both suspended impurities and harmful germs, which have to be removed before the water can be consumed by humans. Removal of suspended impurities is carried out by sedimentation and filtration. Removal of germs and bacteria is done by chlorination. Water is colorless and odorless, and has a slight taste due to the presence of dissolved salts and gases. It is a universal solvent, and a poor conductor of heat and electricity. The melting point of ice, or freezing point of water, is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Water is used for drinking, bathing, cleaning, cooking, preparing medicines, in chemical and pharmaceutical industries, for generating electricity, and for transportation. Conservation of water is the means of preventing wastage of water. Water gets polluted due to human activity.